Hello, and thank you for your interest in my presentation. My name is Dr. Chris Whitman from the Wells School of Architecture, Cardiff University. The work that I'll be sharing is part of my ongoing research looking at the low energy retrofit of historic timber frame buildings. Specifically today, I'd like to talk about the building performance evaluation of a 14th century Pargetted house. There exist preconceptions about the performance of historic and traditional buildings, with the assumption that the older a building, the less energy efficient it is. However, there is now research that challenges this, but we need to be careful that this does not form the basis for further generalizations. As such, there is a need for building performance evaluation to inform sustainable conservation on a case-by-case basis. This particular case study is a Grade 1 listed 14th century hall house in Saffron Walden. It's a timber frame construction with a timber frame infilled mainly with wattle and daub, but with some brick nogging. The ground floor has been underbuilt with brick at a later date. Perhaps its most notable feature is its 17th century pargetting or sculpted plaster. This was described by the architectural historian Nicholas Pevsner as amongst the most precious in Saffron Walden. When it was built in the 14th century, it was built to a typical hall house configuration with a central double height hall and cross wings. However, it was subsequently divided into two dwellings. The current conservative repair aims to bring these two dwellings back into one house, suitable for 21st century living whilst maintaining the heritage values. The methodology of the building performance evaluation used in situ measurements of internal hydrothermal comfort, pressure testing to measure air tightness, thermography, in situ U-value measurements, in addition to digital simulation of energy demand and frost risk analysis using therm. During the monitoring, the building was unoccupied due to the ongoing conservation work. As such, only conservation heating to the upper floor was in place. We can therefore see that most of the spaces perform badly in terms of internal hydrothermal comfort, with all of them not reaching comfort levels for less than 40% of the time. When we look at the reason for this, we can see that, especially on the ground floor, that high humidity is a problem. However, this is probably due to the current uncontrolled connection to a subterranean cellar. With the pressure testing, we can see that there is a decrease in the air tightness since the last measurements in 2012. This is due to the removal of inappropriate 20th century internal finishes. When we look at the two properties joined together, we can see quite a considerable air change rate at 56.6 air changes per hour. However, this is due to the previously mentioned uncontrolled connection to the cellar, in addition to connection to roof voids. These and the internal finishes are issues that will be addressed as part of the conservative repair. And therefore, it is hoped that the air tightness will be returned to that of 2012 or improved. However, future monitoring is recommended. With the thermography, we can see that the weakest areas are the single glazed windows, the protruding jetted floors, and the floor of the carriageway. We can also see a difference between thicknesses of pargeting and a difference between the pargeted upper floors and the underbuilt brick floors, the underbuilt brick ground floor. With the U-value measurements, the initial measurements at locations M1 and M2 showed U-value measurements surprisingly good at 0.85 and 0.64. These were a lot better than we expected. So further investigation of the thermography showed that there was a problem with the location of our measurements, these being over the top of a previously unknown timber member. Therefore, over the winter of 2019-20, Further in situ U-value measurements were taken at positions M3 and M4. This showed a slight difference between the thicker pargeting, and when compared to results of other non-pargeted timber frame buildings with values around 1.7 to 2.9 watts per meter squared Kelvin, we can see that the pargeting is improving these values, and potentially we could think of it as an early form of external wall insulation. The current heating demand was simulated at 179 kilowatt hours per meter squared. However, if the air tightness could be returned to that measured in 2012, this would reduce to 96.6 kilowatt hours per meter squared. A further 17% reduction could be achieved if both floors, the floor of the carriageway and the roof, was insulated. However, we only see small reductions with the introduction of internal wall insulation. And with these, there was a concern over the increase in the risk of frost damage to the 17th century pargeted facade. In order to look at this in more detail, simulation was used with therm, looking at both the current state and 3 thicknesses of internal wall insulation. With an internal temperature of 21 degrees and an external of 0, we can see that with no insulation, that the external surface temperature of the pargeting is 1 degree. With 25 millimeters of internal wall insulation, this is reduced to 0.4 degrees C, and with 100 to 0.2, getting very close to freezing. Given the significance and cultural value of the pargeting, this risk outweighs the benefits. Therefore, in conclusion, we can see that the use of building performance evaluation has enabled a greater understanding of this historic property, which can now inform the continuing decisions in its conservative repair. Some key findings are that the pargeting appears to improve U values of the timber frame wall, acting as an early form of external wall insulation. The conservative repair work removing inappropriate internal finishes has reduced the air tightness. However, it's hoped that the new fascias that will be installed will rectify this. If this air tightness can be returned to 2012 or improved, and the roof and floors are insulated, then potentially we could see a reduction in energy demand of 55%. However, the use of internal wall insulation is not recommended due to the increased frost risk to the pargeting. The research is an example of how building performance evaluation can play a role in our understanding of the complex performance of our historic built environment and the challenges that face us in balancing the conservation of heat and power and the sustainable conservation of our heritage. Thank you very much for your time. If you have any questions, I'll be more than happy to answer them, either during the conference or by email. Thank you very much.